with our math right now. So take a look at example 1. I'll let you read that and I'll talk about it with you in a second. So here it says that the price, let's say of the pen, is P, and it can change. Now, what can my price for this pen be? They've given me these restrictions. The price of my pen has to be bigger than 0, which means I'm not giving it away for free, okay? So I have to charge at least a penny, all right? But it can only go up to $20. We're not gonna charge more than $20 for my pen, for my item, okay? So we're giving you a restricted domain price point. Okay, so your price for this pen, in order for it to be marketable, has to be between $0 and $20. Okay, so you've done some research preliminarily, and that's what we came up with. We've also noticed a trend. Here's what they noticed. Now, you won't have to notice this for yourselves unless you're going into the business world and you practice this in economics class and in business calculus and all those classes. But if this is your last class that you take with us in algebra, they'll give these to you, okay? So they'll say, okay, here's the relationship we noticed. We noticed that every time you raise the price of the pen by $1, the demand dropped by 5 pence. That's what this is saying. For example, if I charge $1 for my pen, plug that in and we'll know how many pens we expect to sell. X is the demand, right? So here we go. 1 times -5, that's going to be -5, plus 100. So when the pen is only selling for $1, I expect to sell 95 pens, don't I? But what if I raise the price of the pen to $2? 2 times -5 is -10. Plus 100. So when the price of the pen is $2, I only expect to sell 90 pens. That makes sense. When I rose the price by $1, the demand dropped by 5 pens, didn't it? What if I sold the pen for $10? That's still allowed, right? So let's do it. 10 times -5, that's -50. Add it to 100, I only sell 50 pens. So I'm not gonna probably charge that much for this pen. And if I charge $20, look what happens. 20 times -5 is -100. No one wants my pen. Sad, okay? And so that's why we trapped it right here, because beyond that, now people are basically charging us money, okay? At that point, it's negative, so it wouldn't make any sense. Okay, so this is what we call the demand equation. It's the relationship between the price and how it affects the demand. Okay? Every single thing in life has its own demand function. Okay, so the pen that we just created, it has, let's say, this made up one, right? But for example, a certain car, a certain phone, same thing. They know, they've done enough research and data gathering. They know exactly where they can put their price and still make a profit and still have decent demand, okay? So what we're gonna come after in this equation in a moment, we're gonna come up with our own equation for revenue, but our goal is to figure out what should we set the price for so that we can maximize the amount of money that we bring in. That's the end goal, right? If you're a business, that's what you want, maximize revenue. Okay. So let's begin. To do this, rather than just picking random prices, we're going to do it mathematically. We're going to come up with a revenue function. Now in this class, we will tell you what we want our function to depend on. So we'll tell you, please come up with a revenue function that depends on X or that depends on P. In real life, if a business was interested in a revenue function, they would tell whoever the mathematician is that they hire, we want our function to depend on the price or on the demand. They let the person know what they're interested in depending on. But they're telling you in college algebra what to do. So they're saying, okay, let it depend on demand. Okay, so let's think about this for a moment. If you were coming up with your own revenue function, we had a discussion about it on the first slide. Revenue, which is the money coming into a business or to a household, is equal to the price of the item, which is also a monetary amount, times the demand for the item, how many items we expect to sell. Okay. That will always be your revenue function as long as you're not having any outside funding come in from Sam or from someone else, right, investors. Assuming the only source of income is you selling items for a certain price. Okay, that's the revenue function. Very simple situation. If that's the case, couldn't I use letters to write this? Like instead of revenue, I'm going to write capital R. I could do that, okay.
Yeah,
instead of price, I could use little p. Instead of demand, I could use little x. So p times x is equal to r. We can always set that revenue function up that way, assuming there's no outside funding. All right. So what do we need to do? Well, it says, okay, that's great. You built a revenue equation, but there's one other thing they've asked us to do in terms of X. So that means they only want their revenue to depend on one variable. Now, right now, you might not see this as a big deal because if I just told you, hey, the price is always $5, put 5X and you're done, right? Okay, that's linear. But right now we're saying the price can change, right? It can vary. It's a variable, okay? So we have two variables, two things that could change. We don't want two variables in our equations. Whenever possible, we want one variable, okay, to depend on one variable. So they told us, please depend on X. They'll tell you what they want you to depend on, okay? So what we need to do then is get rid of P. But how? Good news. They've given you the relationship between X and P, haven't they? In the demand equation. Because they've given you the demand equation that said the demand goes down by 5 pence every time you increase the price by $1, and assuming it starts at 100, where P has to be greater than 0 but less than or equal to 20. Sorry about that parentheses. Greater than 0 but less than or equal to 20. Okay. So since they told me that, if they said you can write the equation in terms of P instead of X, then I would have kept P the way it is, right? And I would have tried to get rid of X. And the way I could get rid of X is by replacing it with negative 5P plus 100. I could substitute that right there. But they've told me to write my function in terms of X, which means I have to get rid of P. Where is P? Right there. Go ahead and take a couple minutes and get P by itself, and then we'll be able to substitute for P. So your job is to solve for P right now in the demand equation. Get P by itself.